in part B, we have x squared plus y squared equals 45, not a line, and x minus y equals 3. Is that a line? Yeah, it is. You could put it in y equals mx plus b form easily. What does x squared plus y squared equal 45 graph to be? It's an equation I'd like you to be able to recognize for the final. Recognize the shape that it graphs to be. If you think about the standard form of a circle, remember it was x minus h quantity squared plus y minus k quantity squared equals r squared. Doesn't this kind of look like that? So you should recognize that x squared plus y squared equals 45 is the equation of a circle. Just have that in your hip pocket. It's one of those standard equations that you're going to need if you go on in math. Okay? What would be the radius of that one? The guy on the right side is r squared. So square root of 45 is the radius. Yeah. Okay, all I want is to draw a picture of a circle. And then I want to draw a picture of a generic picture of a circle. And then kind of a generic picture of the line x minus y equals 3. Would the slope be positive or negative on this line? Think about it. See if you can use your mental powers. And okay, if you subtracted x, it'd be a negative x, right? On that side. But then if you multiplied through by negative to solve for y, it'd be positive. So in other words, if you put it in y equals mx plus b form, m, the coefficient of x, would be positive. So all I'm trying to do is get you guys to think big picture-wise. I'm not looking for details here. I just need, when you graph a generic line, you have to know whether or not the slope is positive or negative. So it's going to be a positive slope. So if you graph a generic line, then it would, it'd be, I don't know how steep it would be, but I do know that if slope is positive, it goes up from left to right. So what I'm trying to get you guys to think about is, okay, how many solutions could you have maximum if one of your equations is a circle and one of them's a line? You could have two. The line could intersect the circle twice, right? What other solutions could you have? One, if it just kind of kisses the curve, like right there, kind of, sort of, right there. And then, could you have none? Yeah, a couple different ways. The line could lie above the circle or below the circle. I'm guessing it's going to intersect the circle. Otherwise, it'd be a boring problem. What if there is no solution? What do you think is going to happen? Remember, when there's no solution, like with the parallel lines from what felt like a million years ago when you solved linear equations, you just got a false statement. Remember that? You got like 0 equals 5 when you tried to solve it using either elimination or substitution. So that would happen with these equations too. You just get a false statement. Okay. So did you actually need to know any of this geometry to solve this problem? No, you could just use the same technique I showed you in the last problem. But I think if you know the geometry behind it, it'll definitely help you later on. Because sometimes we use computers and solving by graphing on computer or calculator to get the ordered pairs if it's a really tough couple of equations to solve. But on this one, couldn't you just use substitution again? Here, it's not way easier to solve for x, but it is a little bit easier. In the second equation, you guys see why? Yeah, it's really easy to add y to both sides, and then you don't have a negative sticking around that might mess you up. So my suggestion, if you use substitution here, would be to solve the second equation for x by adding y to both sides. So you get x is equal to y plus 3. Does everybody see that? All right, what do I do? Substitution method, you guys. So this should be familiar territory. What do I do then with that y plus 3? What equation do I have to plug it into? No choice. The top one, the one I haven't touched yet, right? And I have to plug it in for x. So don't mistakenly plug it in for y, right? We want to get the same variables, the same variable, singular, in that equation. Okay, so plug it in right there. You need parentheses where that x was on the right here. You need a set of parentheses there, parentheses squared, and then in that set of parentheses, you're going to go ahead and plug in the y plus 3. So you have y plus 3 quantity squared instead of x squared. And then you have plus y squared equals 45. And although this solving nonlinear systems is new, the details aren't new. This is now a quadratic equation. So how would you solve it? Y plus 3 squared, y plus 3 quantity squared plus y squared equals 45. What would you do? Yeah, you don't have a choice. We can't get fancy here. There's no substitution that's going to help. Just multiply everything out, combine like terms, set it equal to 0. That's the plan. And then hopefully it'll factor. If not, you can use the quadratic formula. So, all right. What's a quick way to multiply out y plus 3 quantity squared? Square the first guy. What's that? Y squared. Take the first guy times the second guy, double it, right? So what is that? And then you, because it's a plus right here, you add it in, right? If it were a minus right here, you'd subtract it. And then what do you do with the last guy? Just add it and square it, or square it and add it, right? And then we have plus another y squared equals 45. See all this review we're getting today? Okay, how many y squareds do you see? I see 2 of them. 2y squared. So add both of these up. And then what, plus 6y. Can we go ahead and take care of the 9 and the 45 right away? What can we do to both sides? Well, yeah, let's get it equal to 0, though. So let's subtract 45. And then what do we get? Minus 36. There you go. Minus 36 equals 0. Okay. Be nice to yourself. What should you do before you try to factor this thing? You could either factor out of 2, or since it's an equation, divide both sides by 2, right? Get rid of it altogether. So divide the left side by 2, you distribute the division. Division distributes just like multiplication. So you end up dividing each individual term by 2. I'll do the right side for you. Let's see, 0 divided by 2, I think that's 0. That was tough. Okay, you guys do the easy side. I'm just kidding. I did the easy side. But go ahead and, what do you get when you divide by 2? Y squared, you get y squared plus 3y minus 18. Is it worth trying to factor it? You bet. So 2 parentheses, we're going to unfoil that baby. Y, and then you're thinking plus 6 and minus 3. So minus 3 plus 6. 2 numbers whose product is negative 18, definitely. Minus 3 and 6. And then whose sum is 3. Works. Okay, set both factors equal to 0. Either y minus 3 equals 0 or y plus 6 equals 0. Which means what? Y equals 3 or y equals negative 6. Now, you have to be really careful here. There's 2 mistakes you could make. The first mistake is to stop altogether and think, I did enough work. I'm done, right? So why aren't you done, first of all? What are you looking for? Are you looking for numbers or points? You're looking for ordered pairs, points. Those are the solutions, right? Okay, so the first mistake is you could just stop. You could think enough is enough already. I got some solutions, I'm done. You're not done. The solutions are points, not numbers, not individual numbers. And then the second mistake you could make is getting the order wrong, right? So, okay, you have y, you need x. Once you get x, you've got to make sure that, for instance, y equals 3 is the second coordinate, right? And y equals negative 6 is the second coordinate for the given x values you get. It would be very easy to switch those around because you're used to thinking x, y left, you're used to thinking of the first answer as your first coordinate. But it's not here. It's this, you got a couple of second coordinates. Okay, so with that in mind, let me scroll back up a little bit. To get the first coordinate that goes with a second coordinate of 3, what do I do? Which equation? Yeah, make your life easy. Plug it into the one that's already solved for x, this one, right? I mean, you could plug it in any of the top, either of the top 2, but it would be easiest to plug in the one that you solved in terms of y. In other words, you got x by itself and then whatever in terms of y on the other side. Okay, and if we plug that in then, what do we get for x? X is equal to y, which is 3 plus 3, which is 6. So, okay, let's write down that solution right now. What's the ordered pair? 6, 3. Wouldn't it be really easy to reverse that if you weren't thinking 3, write it as 3, 6? So be careful about that. That happens a lot. So it is, the x is the first coordinate, and the y that you already had is the second coordinate. Okay, now let's do the same thing to get the x coordinate that goes with this guy, y equals -6. Plug it in the same place. And what do you get? X equals -6 plus 3, which is -3. What's the solution? -3, -6. There you go.